Morning, apologies for the change there. So this is some of the work that I did in my Masters, different to what I presented last year at this conference. So slightly different angle, different viewpoint, different part of the story. And it's also published, so you can also read the paper. So as we've talked about and know, bush encroachment has become a major concern. Heavy grazing, we know, can cause bush encroachment, be a causal agent rather, and more recently CO2 is predicted to increase the rate of bush encroachment as well. So in Ithala Game Reserve, management wanted to know whether their fire management regime was effective, and we decided we would go alongside of them and try and answer the question and look at what their fire regime is doing to the bush, whether it's being effective in controlling the bush. Here you can just see a fire frequency map of the reserve. So we used long-term observations collected in Ithala over 30 years, which is fairly long for most ecological studies, to assess the woody vegetation change in the game reserve. And we also used textual analysis of aerial photographs to detect changes in the woody vegetation from 1943 to 2007. And we also sampled woody vegetation in areas of different fire frequencies, as you saw on the map there, that were comparable. And lastly, we collected daily rainfall records from 1905 to 2009, and these were analysed in a time series analysis. Okay, you can see just an example here of one of the aerial photographs, area in Ithala in Gubu Loop, and you can see fairly heavy encroachment there, pretty dramatically from 1990 to 2007. Okay, so the textual analysis revealed the following, and you can see in the graph there, the x-axis is the year, 1943, all the way through to 2007. 4 sampling periods there, 1943, 1969, 1990, and 2007. As you can see, as was illustrated in the photos, most of the encroachment occurred from 1990 to 2013. The different dots and lines on the graphs there, dotted lines, are in areas where fire was from biennial to 0, and the solid lines, they were more or less biennial fires. And what you can see there is a switch over in the mean density of woody individuals from the period 1990 to 2013, and areas where fire was suppressed, the ingress of woody plants into savannas was at an increased rate. Overall tree cover and density increased significantly by 32.5% and 657 individuals per hectare respectively over the 64 years analysed. Before the proclamation of Ithala in 1972, the increases in the woody vegetation were non-significant, and this was determined from the textual analysis. So what do we know about fire? How can we answer what's going on here? In nearby savanna, just here's a picture to illustrate a point, the increased woody aggression where there's no fire. This is in Fiflosi, and the Zululand Tree Project fire trials there. On the left there, you can see less woody individuals, structures being decreased over all the categories. On the right, where there's no fire, general increase in woody vegetation. So fire can explain some of the increases there. And definitely fire suppression was significant in the reserve. What about at a species level, the effect of fire frequency on the species? You can see here the change in the tree densities from the year 2000 in the light columns on these graphs, and then the density in 2009, the dark columns. The numbers on the bottom are the stem size classes. So class 1 being 0 to 1 centimeters, class 2 0 to 10, and then upwards in 10 centimeter intervals from there. You can see dramatic increase in some of the species from 2000 to 2009, and there are some relics of herbivory patterns here as well, with the more palatable species decreasing in Ithala as herbivore populations increased. Some of the species had dramatic increases in recruitment. For example, Euclid CRISPR in graph G, close to the bottom left there. Lots of high recruitment of that species, also high recruitment of Euclid natalensis in these areas where fire was suppressed. Searsia as well increasing a lot. Acacia caffra increased quite a bit of recruitment. Acacia cru, similar story with increased recruitment. Acacia nilotica, on the other hand, population seemed fairly stable with a reverse J-shaped curve there. Acacia nilotica being the top right-hand graph there. That's just pulling up the increased recruitment from 2000 to 2009. And then also the increasing density in Searsia for RISA and Euclid species. Okay, so in the Ngubulip is an area in Ithala where fire has been suppressed. There were large changes in the density of plants, and we noticed a definite trend in palatable versus unpalatable species. Unpalatable species were noted to increase fairly dramatically, whereas a palatable species decreased in density, and that was a clear significant trend. The graph there is showing the percentage density changes in these species. Just looking at the extremes, on the right-hand side, Berkemia zara, a species that is selected for. You can see the percentage change there, increasing there. One thing to note about Berkemia zara, though, is that it is also a species that establishes under canopy cover. So that's one of the dynamics that the data you have to deal with as well. General succession. From a savanna to a more thicket state, you get an increase in these forest precursor type species, such as Berkemia zara, Euclid natalensis as well, you can see increasing there, Digristacus as well, and then a decrease in species like Acacia duralia and Merida on the left-hand side there that are selected for. That's just highlighting the decrease of some of the unpalatable species, and there was also total disappearance in some of the transects of Acacia davia, which is known to be highly palatable, and Elomolophi as well. Then just pulling out in that graph, as I mentioned, the dramatic increase in unpalatable species. So there's definitely something going on with herbivory here. And then the increase in forest precursor species on the right there, and that's a lot of recruitment. Did a constrained canonical analysis on the data to determine the effect of fire frequency. Other environmental variables were also assessed, and by stratifying the sampling, we managed to put out the effects of fire frequency. As fire frequency increased, there was a high density of savanna species, which is pretty logical. And then decrease in fire frequency, we get more Euclids coming in, forest precursor species, such as Natal lavender as well, Heteromixus on the top there, Papia capensis, Circe guenzai, also Dicrostachys cinerea was coming in at great abundances and a decreased high frequency. Then the results from the rainfall. As you can see, deviation in rainfall from 1910 there to 2012, 2010. There's quite a bit of variability and it's hard to analyze it just looking at that. So we test out some of the variability in the time series analysis by plotting rainfall events. On the top, or the x-axis is time once again. On the y-axis we have frequency of events, the bottom three graphs. In the top graph we've got the annual rainfall. You can see a general, there's a decrease in rainfall from 1910 to 1930 and then a general increase in the mean annual rainfall. The next plot down from that, from the top one, shows the trends in the rainfall events from 0 to 10 mils, and you can see a decrease there in rainfall events, smaller rainfall events. Then the bottom two are larger rainfall events, and you can see a general increase in those events. Particularly, let's just pull out some results on the bottom graph there. There's a fairly dramatic increase from 1990 to 2010 of rainfall events over 20 mils. So this had to be taken in consideration in the analysis of what is causing bush encroachment. So just to explain our hypothesis as to what's happening with the rainfall. We know that rainfall is very significant in our systems, water drives systems. The increase in mean annual rainfall, mean average rain, and the intensity of these rainfall events may explain the woody vegetation increase from 1943 to 2009. Grasses are known to be brilliant competitors compared to woody species, rapidly absorbing nutrients and water, and this has been shown in a number of studies. So what happens when you get a light rainfall event? The grass is quickly absorbed, all the moisture, and not much infiltrates into the deeper soil layers. However, you increase that storm up there, larger rainfall event, the water table fills up, and more rainfall is available to woody plants, only woody plants, because grasses don't have their roots deeper than about 1.5 meters in some cases, so the hyperinians and pogums. So you have increased infiltration with these high rainfall events in most of the savanna. And this allows woody plants to have sole access to more water resources in the deeper soil layers. What about the herbivores? How they have affected the woody encroachment in Ithala? So after the proclamation, as I've briefly mentioned already, herbivore populations increased, and their spatial distribution has influenced the accumulation of grassy biomass, and this was particularly prevalent or visible in the Ngubu Basin. For some reason, they congregated there, and biomass was decreased, and they weren't actually able to fuel fires there, stimulating woody encroachment, and then they couldn't burn. So in these areas, we've got increased woody plants because of the suppression of fire. Grazing, just to illustrate a point here, this is photos from Ithala. On the left-hand side, you can see a pic of an exclosure where there's virtually no grazing. On the right, where there's heavy grazing. Heavy grazing has clearly reduced grasses' ability to withhold the encroachment of woody plants. If you look on the bottom right-hand picture there, where there's heavy grazing, so grazing seems definitely in Ithala. You can definitely say that it influences, stimulates woody encroachment, and it has been able to, particularly in Gubu Loop area, and should be a concern in the future. So to sum up, the increase in woody vegetation in Ithala coincided with a decrease in palatable species relating to herbivory and an increase in unpalatable forest and thicket woody species. Palatable species such as Acacia davia have even gone locally extinct in Athola. So, general picture to sum up: change in rainfall patterns has resulted in an increase in woody encroachment. Increase in herbivores has decreased the fuel load, suppressing the ability for fire to play its role. And as well, preferential selection and browsing has allowed unpalatable species to go unchecked and resulted in their encroachment. So you change your rainfall, increase your herbivores, and you get a changed savanna. More forest species coming into the thickets, decrease in fire, increased woody encroachment. Thank you.